Hello friends and welcome at my channel. Today guys I would like to show you how to compute the greatest and the least value of a polynomial of degree of 3 with just an interval. So we are bounded by an interval and we're not given the total real numbers. So let us see if we have f of x equals to x cubed minus 3x plus 3, and the interval the x value is alive is from minus 1.5 to 2.5, so 2.5. All right, so basically what we're doing, we are producing the first derivative, which is 3x squared minus 3. We can put 3x squared minus 3 equal to 0. We're dividing it by 3. We're going to get x squared minus 1 equal to 0, and that means x1 is minus 1, x2 would be 1. We are then going to the second derivative, which is 6x only, and as you can see the second derivative at minus 1 would be minus 6, which is less than 0. So what we're basically having is the max, because the function afterwards is going down, and the second derivative at 1 would be 6, which is greater than 0, which is mean. So that's the story so far, right? But is it truly the greatest value, and is it truly the smallest value? Well, let's see. You know what? I'm just, sorry, reinventing the question. I make it a bit easier for me to check the boundaries. I'll just take it from minus 2 to, yeah, let's say 3 would be still fine, okay? So why am I doing this? I didn't want to take like 1.5 to the third power, even though I know it is 3,375. I don't want to work with that, okay? So let's see. So that would be 3.375, by the way, not 3,000. Okay, so the smallest value is at, what do we have? 1, and the biggest value is at minus 1. All right. Can we compute those values? Yeah, well, of course we can. So let us compute f of minus 1. That would be minus 1 cubed minus 3 times minus 1 plus 3. That would be minus 1 plus 3 plus 3. This is 6 minus 1. This is 5. And what about f of 1? That would be 1 cubed minus 3 times 1 plus 3, so that would be 1. So what do we have? We have a max at minus 1, which is this value, so max is at minus 1, 5, and mean is at 1, 1. So far so good. So should we stop here? Well, no. These are local extreme values, so mean and max where the function is bending. This is how normally x cubed looks like, but we have here something special because of the values of the interval. So we're bounded by, well, we said minus 2 and 3, right? So what is the value f of minus 2? That would be minus 2 cubed minus 3 times minus 2 plus 3. So what's happening here? We're having minus 8 plus 6 plus 3. That's going to be 1. So it's actually the same value we previously had. And what is f of 3? That would be 3 cubed minus 3 times 3 plus 3. So what's happening here? We're having 27 plus 3, it's 30, minus 9 is 21. So obviously the biggest value of 5 is not quite the case because 21 is greater than 5. So the biggest value we're going to get on the boundary at 21. And not at local max, which is at -1. And mean is, well, not unique. We have the mean value at 1, 1, and we also have the minimal value at -2, 1. Let us now clarify it and see what's happening. I'm just using software for this, and let us see whether it's correct what I've been doing. So we're taking f of x equals to x cubed minus 3 times x plus 3. So let's see. I said from minus 2 there is the value of 1. Then you see at 1 we have also 1. So these are truly two minima, which is fine. And we stop at 3, of course, and this is way bigger than this max. So that seems to be right. Thank you guys for watching the video. See you in the next one. All the best. Bye-bye.